come up with those partial derivatives, right? So let's do that first. Okay. All right, so the partial derivative of this function with respect to x, I have 15x squared times y to the fourth. Okay. The partial derivative of f with respect to y is going to be 20 x cubed y cubed. The partial derivative of f with respect to x, then x again, is going to be, what is that, 30 x y cubed. Okay. And then the partial derivative of f with respect to y, then y again is going to be, using this one right here, we get, what is that, 60 x cubed, 60x cubed y squared. And now the partial derivative of f with respect to x then y, using this one right here, I get 60 x squared y cubed. Or if we want to do the partial derivative of f with respect to x, y then x, we should also get, using this one, 60 x squared y cubed, which is what we get. Right, so we're happy with that. Now let's create our Taylor series based off all these partial derivatives. So we have f of x plus 5h. So my a is, I'll put it here. My a is equal to 5. My b is equal to -2, right? Okay. So f of x plus 5h y minus 2h is equal to the Taylor series. The first 7 terms of this Taylor series is going to be 5x cubed y to the 4th plus 15 x squared y to the 4th times 5h plus 20 x cubed y cubed times -2h plus, now going to our second derivatives, our second order derivatives, we get 30 x y cubed. I'm going to put the divided by 2 factorial before I forget. 30x y cubed divided by 2 factorial times 5h squared, right? Because this is dealing with x twice, so I get the x is being, 5h is being added to x twice. Essentially, you can think about it like that. Plus, or you can think about it like that, 60x cubed y squared divided by 2 factorial. And then this becomes times -2h squared. Plus, now if I wanted to, I can just combine them together into one, but I'm gonna keep them separate. You can combine them together into one big fraction, but I always forget something, so I need to make sure that I keep them separate, so I always remember to write every single one I need. 60x squared y cubed divided by 2 factorial, and that's be 2h times 5h, so that gives me a -10h. And then I get one more. Exactly the same thing. And of course it keeps going. Okay. So that's our Taylor series about for f of x plus 5h y minus 2h, and our function being 5x cubed times y to the 4th. And again, if I wanted to, and let's put it down here. If I wanted to, I could say let x equal 1 again, just to make our life easy. Y equal 1. Of course, we can let x and y be whatever values we want them to be. I'm just choosing x and y to be 1, just because it's easy to do the math. And h equal to 0.1. Again, I could let h be whatever I want it to be, but just for the sake of just keeping the math easy, that's why I'm doing that, and my board is not that big. But again, I could let x and y be whatever I want. I could let h be whatever I want. Let's approximate. F of x plus 5h, y minus 2h, which is going to be f of 1.5, I believe, and 0.8. Using the Taylor series. Okay. So here we're going to be using this Taylor series that we just came up with for f of x comma y equal to 5x cubed y to the 4th. Okay. So let's plug it in there. So what do we get? We have f of 1.5 comma 0.8 is approximately equal to, just plugging in where x is equal to 1, y is equal to 1. So this becomes relatively easy. You get 5 plus, what's that, 15? Times 5h, which is going to be 0.5. And then we're going to have plus 20, because x and y are both 1, so that makes this easy, times negative 0.2, plus, this becomes 30 divided by 2, times 5h squared, so this is going to be 0.5 squared, plus 60 over 2 times negative 0.2 squared, okay, plus 60 divided by 2 times negative, so 10, oh, this should be, yes, this should be negative 10h squared, right? This should be negative 10h squared. Thank you, guys. Yes, this should be negative 10h squared because it's 5h times negative 2h, which gives me a negative 10h squared. Great. Thank you, guys. Thank you for pointing that out. I know that you were saying that in your head, so I appreciate that. Which is going to be, I believe, negative 0.1 plus, again, another negative 0.1 when that's worked out. And if I did that correctly, again, I'll double check. I should have double checked before. I usually do, but for some reason I didn't today. I have 6.4. And my actual value when I do this, f of 1.5 and 0.8, that becomes 5 times 1.5, what's that, cubed, times 0.8 to the 4th. I have that to be 6.912. So not a bad approximation if all that's correct. So that's kind of the Taylor approximation of in two variables, and that's what I wanted to talk about today. Again, let's stop the video here, and I'll double check these numbers. If there's any errors, I'll let you know in the next video. Otherwise, we'll go to the next part. All right, talk to you guys later. Bye.